All right, so we're just going to talk very briefly about acids and bases. You're going to learn a lot more about acids and bases in Chem 102. So there'll be a lot of holes, a lot of missing information. Just realize eventually you will get to that. I do have the playlist already up, so if you want to search my YouTube channel, you can watch it now if you'd like. Anyways, we're going to define acids as very simply just something that donates / releases H plus. Remember, hydrogen has a proton and electron. So when we're at H plus, it's just a proton. And that's why it's important. It's very reactive, very common in our systems. So when we have H plus in water, it will form hydronium, which is H3O plus, right? H2O plus another H plus. In terms of chemistry, chemists use H plus and H3O plus as interchangeable. So if I say H plus or H3O plus or hydronium, they're all the same thing. So how does one identify whether something is an acid or not? The best way to do it is through your nomenclature, right? We learned how to name compounds, and the acids all pretty much have the word acid in them, right? So if we have HNO3, that's nitric acid. So that's obviously going to act as an acid. And so when we combine that with water, that's going to go ahead and donate an H plus, right? This H right here is going to go to the H2O, and it's going to go as an H plus. So if we think about it, we have two H's here. Another H will be H3O, and then that positive charge carries over, and it's H3O plus. This NO3 now just lost an H plus, so no longer has that H there, so it's NO3, and then it lost a plus sign, so now it's a negative, right? It's a nitrate. So again, this is acting as the acid because it's losing an H plus, right? If you take a look at what's on the left versus what's on the right, on the left it has an H plus, on the right it does not have an H plus. And then every time there's an acid in reaction, there's always got to be some kind of base. So they always come in pairs. And so in this case, water is the base. And it's the base because it accepted this H plus. So acids donate and release H pluses, bases accept them. Or it's pretty much the same thing. They could form hydroxides, which if you think about hydroxide and water, it's the loss of an H plus, so it's accepting that H plus. So the most common types of bases are our metal hydroxides. So something like NaOH, sodium hydroxide, is a base. It will interact with H2O to form a sodium plus ion, plus then a hydroxide ion, and then of course we have our water molecule, right? So you can see that in this case, we formed this hydroxide, so it's acting as a base. This hydroxide can then take an H plus from this water, but then it'll just reform more hydroxides. Either way, we are becoming more basic. However, metal hydroxides aren't the only base that we have. The other more common one in Gen Chem is these amines. So these nitrogen-containing compounds. Remember that this nitrogen in ammonia has this lone pair. And then it can interact with water to form ammonium hydroxide. So NH4 plus and then plus an OH minus, right? We've seen that in lab. In this case, if we think about this NH3 going to NH4 plus, it's accepted the H plus, right? It gained an additional H, it gained a positive charge, so that is acting as the base. If we think about water going from H2O to OH minus, it just lost an H plus, or it donated it, so that's acting as the acid. So note, in this reaction, water is acting as an acid. In this reaction, water is acting as a base. So water can act as an acid or a base. And that's called being amphoteric. Overall, we're not going to spend too much time on acids and bases. just be able to look at a reaction and know where that H plus moves, identify it as an acid-base reaction, and then I'd be able to identify what's acting as the base or what's acting as the acid.